Wayo, 2.4. Guess what? Nearly Halloween. Get out the Jolly Ranchers new bowl. Shower us with Jolly Ranchers. Yay. Answer some math questions, right? Get a reward. Bam. So thanks again. We are doing a 2.4 here, helping you out. Let's see. So don't forget some of the basics, of course. Like the square root of 72, try to break it down into the biggest possible factor. So such as what? 9 times 8, but there's something bigger. What about 2 and 36? That'd be good, 36 and 2. Don't forget there's also -1 in there that are all being square rooted. Right, so we broke it down into 36 times 2 as well as the -1. Don't forget the square root of -1 is just an I. And then the radical 2 can't do anything else, but the square root of 36 is 6. Wayo. There we go. So if you have a graphing calculator, you can also double check your work. You just have to make sure your mode is in real numbers like that. Good. Okay, so if we did the square root of -72, we would get some crazy answer like that, which is the same as second I times radical 2. Yeah, we did it right. Let's see here. So don't forget, f times g times x. So you just have to multiply, right? So you take f, which is 2x plus 3, and you multiply it with g, which is x squared minus 4. So go ahead and seashell that guy, Good. Don't forget f of g of x means composition, not just multiply. And so you're taking g and plugging it into f. So take g and plug it in there for f. In place of that one, so you have 2 space plus 3. And you did originally have, and so that was 2x plus 3, that's what f is. But now you're going to take g, and you're going to plug it in there. So the x goes away, and you're left with the x minus 4. Don't forget to distribute, combine like terms. Okay, here it is. Mrs. Pack plans on building an animal pen for pigs and chickens, right? So this is an even one, so I'm going to let you practice on your own. Just realize that there's only 3 widths and 1 length because the barn is covering that side, so she doesn't need that in her perimeter. And so that means you're going to just have 1 length plus 3 widths, equaling the 120 feet for fencing. So don't forget that. That'll make it easier to solve at least. All you have to do is minus the 3w over. Don't forget area is length times width, good. So keep on doing that one. Try to get the, with your equation, get the width. And then the vertex. So the y value of the vertex, remember that's your maximum. And then you use that to get your length. Come on in, just making a video. You go down that way if you want. Just making our video. Okay, let's see here. So turn the number and type of zeros for each quadratic equation. Ooh. Okay, so just based on its rough graph is what it says there. And so if we can just go ahead and graph each one of these. Remember, this is in vertex form if you got a square there. And so that's going to be our h there as well as our k value. Now don't forget, remember it's opposite sign. So instead of a -4, we have a +4, -2. So we go right 4, down 2. There we go. Now rough graph means that we can check the sign to see if it's going up or down. And since there's not a negative, no negative, that means we have to assume that it's positive and going up. Just making a video. Just going up. And so that means we are going to have 2 real x-intercepts. So that's going to be 2 real zeros. For that one, just looking at the rough graph, right? So if you take a look at this one, which is right 1 down 5, but then it's pointed downwards, right? 1 down 5 is pointed downwards. So that means probably no real ones there. We do have like imaginary ones though, imaginary ones, which is awesome. Let's see here. Number 9 though is also going down. Just making a video for you guys. So then right 6, 1, 2, 3, 4, 5, 6. So that's going to be right here. And it's going down. Does it cross the x-axis anywhere? It does. It actually crosses in one place, right there. So technically, there's one real 0. I mean, it's 1 0 with a multiplicity of 2, basically, because it repeats itself twice. X minus 6, x minus 6, there's 2 of them. So multiplicity, but we'll just say 1. We'll just say 1 0 for there, because it only crosses the x-axis, barely touches it at one spot, and that's right, 6. Whoa. Determine the number and type of zeros for each quadratic function using the discriminant and the quadratic equation. Let's take a look there. Ooh. So, the discriminant. Remember the formula for the discriminant? Let's see here. The discriminant is the square root of b squared minus 4. So negative b plus or minus x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Don't forget a plus there, plus a negative 4ac, to be honest with you. Because too many people forget that it's actually a negative. You're multiplying with the a and c. So we'll finish off this one, and then we'll let you watch my next video after 7th period is done. Here we go. So our a is 5, our b is 10, and our c is 5. Whoa. So then we do the square root of b squared, which is 10 squared, which is 100, plus a negative 4ac. 5 times 5, 25. 25 times negative 4 is 100. Whoa! What's the square root of 100 minus 100? So that's just 0. So what does 0 mean? What does 0 mean? So 0 means in your discriminant that on the Pythagorean, the quadratic formula, that square root is just going to go away. And so since it's just going to go away, x equals negative b plus or minus the square root of blah, 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 discriminant all over 2a. So if this goes away, you're just left with negative b over 2a. And so negative b over 2a is just one root. Just one. Just one real root. One real root. So one real root is our answer. So thanks for watching. Don't forget to answer questions in class because you get show your answers. There we go. Thanks for watching. Bye for now.